I'm going to bring up Steve Kinney, who's going to talk about making music in the browser. So please, round of applause for Steve.
Thank you. Hello, I'm Steve, and I am the co-director of academics at the Turing School of Software and Design. What is that? Well, I'm glad you asked. It's a 7-month developer training program in Denver, Colorado, focusing on Ruby, Rails, JavaScript, and the like, taking people who want to become great developers and making them really great developers. So if you're interested in hiring great junior developers, come talk to me. If you're interested in mentoring up-and-coming developers, also I'd love, love, love to talk to you after this. Cool. So I want to talk a little bit today about doing fun and creative stuff in the browser. Can everyone raise your hand if you are into having fun and being creative? If you're against it, you can leave your hand down. All right, I don't want to force anyone to be into fun. So we're talking a little bit today about making some music. Right? And I don't really have a great way to tell you this, so I'm just going to tell you it right now. Somebody put a synthesizer into your web browser. I honestly don't actually know when it happened, and you'd think I would have looked that up beforehand, but it's cool. But it's in most of your web browsers, soon to be Internet Explorer in the rest. My apologies to the Opera Mini user. And so how do we go about using this synthesizer that's built into our browser? Well, it starts with some context. If you've ever played around with HTML5 canvas, the very first thing you have to do is get a canvas context. And the same thing is true for using the Web Audio API. So we start by creating an audio context, which is pretty straightforward to do. We have to, for Safari, we got to do a little bit of a rigmarole with some vendor prefixing, but we can abstract our way around that. It's fine. And basically, we just say new audio context, and we get back an audio context. And what exactly is an audio context? Well, it's a place where we start to work with some different audio processing nodes. The most important one to start out with is this idea of a destination. Right? The destination is the operating system and whatever it is it does to get sound from the OS to either your headphones, your earbuds, your speakers, what have you. The other thing that we need is the ability to actually make some noise. Right? And there's a bunch of ways to do that we'll cover in a moment. What's really cool about the Web Audio API is that we can take the noise that we create and begin to process it. We can add delay, reverb, gain, all sorts of fun stuff. So let's start by talking about this whole context and the destination that we can produce sound through. It's really easy to do because when we created that context before, it has a destination property, and that's it. We're done. Step 1, complete. The next thing we're probably going to need to do is to create some sound. There's a bunch of ways to do that that we'll cover, but one of them is to take sound from an audio file. That's been done. The other thing we could do is we can take the user's microphone and maybe pump in some sound through an audio input or something along those lines. That's cool. We can also create our own sound from within the browser. And for the purposes of today, that's what I'm most interested in talking about, making music with the browser in the browser. So what is an oscillator? An oscillator is what we use to produce tones inside the browser. And it basically creates a sound wave, right? And sound waves have frequencies. As that frequency goes up, as the wave gets smaller and smaller, the pitch gets higher. And a wave has amplitude, which is how short and tall the wave is, and that allows us to have some amount of volume to it. Creating an oscillator, super easy. That context we created before, it has a create oscillator method. That's really useful for creating oscillators. So we can actually just call that method, and we get ourselves a fun little oscillator that we can work with. So the next step is we've got an oscillator, we got the destination. We probably want to connect the two of them. And the metaphor I really like here is it's plugging a guitar into an amp, right? In this case, a keytar, because why not? And that's really easy to do because the oscillator has a connect method. And we basically take the oscillator and we connect it to the audio context's destination. And finally, we're not actually producing any sound yet because we haven't turned the oscillator on. So let's go ahead and do that. So the method is pretty straightforward. The one thing you might notice is this 0. That's when you want it to start. If you give it a value of 1,000, it'll start in 100 milliseconds or a second. If you give it 0, it'll start right now. Chrome and Firefox don't actually care if you put anything in here. Safari does. So if you would like to if you're wondering why your thing is not working on iOS, that's why. Lastly, if you're like me, you will have probably set the pitch way too high. You're probably wearing earbuds, and you're probably shrieking in pain at this point. So you're probably going to want to stop this thing. And that's Very easy to do as well. And again, you're probably going to want to stop it right now. The problem is if you want to start it again. Once you stop an oscillator, game over. You're not turning it back on. You're done with it. Go get a new oscillator. The other thing you might want to do is then disconnect it. If you don't disconnect it, the garbage collector never grabs it. It stays around forever, and eventually you get yourself a nice, friendly memory leak. So when you disconnect it, the garbage collection comes around and takes it away. And you can create a bunch of these really easily. But we talked about this before. What's really cool about the audio API is that you can actually put in these intermediary nodes. So what if, instead of having to like get rid of a bunch of oscillators, we simply put something in the middle that would turn the volume up and down? Right? When we turn it down to 0, it's off. When we turn it up to 1, it's on. It turns out we can do that with a gain node. That gain is pretty much volume for our intents and purposes. There's no mystery in how you create a gain node. It's just like how we create an oscillator. We've got this create gain method. And so we create the 3 things that we need. Step 1 is we hook up the sound source, in this case the oscillator, to the volume, or the gain node. That's really straightforward. It's kind of how we did it previously. The next step is then we take the gain node and we hook it up to the destination. So now we've plugged our guitar into like a volume pedal, the volume pedal into the amplifier, and we're ready to rock. Cool. At this point, we can start up the oscillator. When we want it to be loud, we turn the gain up to 1. When we want it to be quiet, we turn the gain down to 0. We don't actually have to like get rid of oscillators and create more oscillators. We just take it, give an oscillator, plug it into a volume pedal. Great. Awesome. And we can turn it on and off as we need to. So let's take a look at this in action. So we're at 220 as I begin to turn up the volume. And a sine wave is our default, like rounded, nice, pleasant to the ear wave. We can also try out a square wave, sawtooth, the triangle. Mostly the sine wave is the nicest. Let's stick with that one. Turn that down. Cool. So we can create some sound. That's great. But making sound is necessary but not sufficient for making music, right? The next step is to actually take in some basic music theory here so we can begin to take these tones that we're creating at various frequencies and make something that's less annoying than what I just exposed you to. So by default, an oscillator starts at 440. 440 is significant because if you ever get like one of those tuning forks to tune a piano, because I all know that in your spare time you're piano tuners, 440 is the default frequency for that. And the way that sound works is if I were to double that frequency to 880, I would get A, but an octave higher. And if I was to have it, I would get A, but an octave lower. The rest of the notes come somewhere in the middle, right? And you might say to yourself, I'm an engineer. I can handle this. What I'm going to do is I'm just going to divide it by 12, and I'll get the rest of the notes. And that totally works. It's cool. It totally works if you only ever want to play in the key of A. Should you, let's say, play in the key of C, because I don't actually know what those black keys do on a keyboard, then you actually need to, you see that this doesn't work. If you start from C and do the same thing, well, D, if you start from A, is different than D if you started from C. So this doesn't really work. So you can try to be really clever, and you can say, all right, I'm going to write this really sophisticated algorithm, and I'm going to like figure out what key they're in, and I'm going to like find the correct tone and shift only to that one. Or you can realize the fact that we solved this like 500 years ago, and just leverage that. So here we have basically a keyboard. And what a piano does basically is it made a whole bunch of compromises. There's a bunch of intervals, and there's a whole bunch of different choices, and then very thick music theory textbooks that you can buy on Amazon for like $100 each and read all about this. But the idea is like we solved this problem. So when you have a problem and a simple solution and a cute name, you have an open source library. That's how it works. And basically, I have a little library called Octavian where I never have to think about this ever again. I pass it A#4, it gives me back the right frequency. And so here it is. I get 466.18164, which I would never remember. And I can also like get a whole bunch of other properties about it. And even better, I have a bunch of different intervals I can use. And I can shift up a major third, up a major fifth. And that's really cool for like creating chords and stuff. So let's actually take a look at this in action. Here we've got let's make a small little piano based off of this. So there's a little app called Audiophonic, because I like to name things. And let's check it out. All right, so I have two options. I can hover over different keys, or I can actually play it on the keyboard. Cool. Yep, mouse moving. All right, so how do we go about building something like this? It's actually not as complicated as it might seem. And this graph makes it seem way more complicated than it is. Basically, we've got a bunch of keys. They're hooked up to a bunch of oscillators. Those oscillators have a bunch of volume nodes, and we're basically turning the volume up and down, right, based on different keyboard events. So user comes in, they press a key, emits a key down event. We basically figure out what key they press, and we turn that oscillator on or off. Little syntactic sugar here, which basically like fires up an oscillator. If we don't have one, it makes it. If we have it, we just turn it on. That's it. When they take their finger off, so we start the oscillator. That's cool. When they take their finger off, we basically stop the oscillator. And that's it. We've created a synthesizer in our browser. So that's cool. The other really cool part is that somebody put a web browser in your synthesizer, right? It's cool to like emulate a piano, but like maybe you should just buy a piano at that point. What's really interesting is using the other APIs that are available in the browser to create some different instruments that wouldn't be possible otherwise. So what if we took our audio API and mixed it with the getUserMedia API and grabbed their webcam? So here we have another demo. This is a demo called Face Theremin. A theremin is that thing that where you hover your hands over it and like it makes creepy sounds from the 60s. Yes, I will allow this. That's enough of that. I literally could do that for the next 40 minutes, by the way. So basically what happens is most of the hard lifting was done by some face tracking library I totally don't understand. But what the library does is it emits face tracking events, which has a whole bunch of properties. I really only care about, in this case, height, which is when I stood back or came closer to it, the size of the box that my face was in. I got a big head, so I had to stand really far back. And the x-axis, which is the right or left. And basically, I take those two properties, I do a little funny business to make sure I don't create like a really obnoxiously high-pitched sound. You can thank me later. And I do a little rigmarole to get the gain to actually be a normal number. And that's really it. All right, let's check out a different combination of technologies. What happens if we took the web audio API and we decided that we wanted to mix it with some WebSockets? Well, there's some problems here. One is like latency, right? Like music, this whole rhythm thing, I never had any of it, but I hear it's important. And so having people on some kind of like even millisecond like latency is not going to work. So what we could do is we can just take inspiration from some other instrument. So this is upstairs, it's the Atom terminal, and you can see there's a little step sequencer here. And basically it steps through each column and plays the notes that are turned on. Kind of like lights out, but for music. And we can create something like that. And we've got 16 different quarter notes, except that like we're programmers, so it's 0 indexed. It's cool. And we have some basic notes. I chose C, E, G, and A. G and A will sound terrible if you turn them on together, but roughly it's a C major chord with an extra note. So it's really hard to make a really terrible sounding music. I mean, I'm sure you can do it, but it should be slightly harder. What happens along that time is that when a user hits one of the different boxes, we send the entire sequence to a server that's keeping track of all the connected users. Then, in that case, Node will go out and send out all the sequences to all the users. And they'll get combined in the browser to make a fun sequence. So let's actually try that one out. I don't need to see my face anymore. All right, so here we go. We can actually do like some root fifth stuff, get a nice bass line going. And then I'm a professional, so I have another browser window open. other sequence is down here. And you could theoretically have 100 people playing an instrument together from around the world. You can't do that with the piano in the other corner of your office. Right? That's something you can only do when you start building instruments in the browser. I'll spare everyone that. All right, final demo. Other cool thing about JavaScript is that it's widely the most popular programming language in the browser. Mostly because it's the only programming language in the browser. That helps. But it's actually like, people have decided that, hey, I would like to do JavaScript on hardware and all sorts of other places, maybe even the server. That's cool. What happens if we start mixing the Web Audio API with some Arduino hardware using Johnny 5? So this is a little kind of demo. I have it sitting here next to me, but this is the kind of prototype for it. And it's got some buttons, it's got a little rotary potentiometer, and Arduino board. And what happens is whenever something happens on the board, that sends a signal to Johnny 5. Now Johnny 5 can also fire up a web server and a WebSocket server. So button comes in on the Arduino board. Next thing you know, it's then sending a WebSocket signal to the browser. The browser will actually grab the Web Audio API and make a sound. So let's try that out. So the moral of the story is my hope today was that we could take you from, I don't know anything about making music in the browser, to, yeah, I could probably do this, right? I could probably play around with this. So music's pretty awesome. The web is pretty awesome. And it's like cookie dough and ice cream. Together, they are really awesome. So there's a whole bunch of things we didn't touch. We didn't actually combine a lot of technologies here. There's a whole other APIs that we didn't even use. There's a gamepad controller API. Bet you never knew about that. I didn't. There's WebRTC, which is the ability to get user media from multiple sources. You can have like multi-phase theremin if you put your mind to it. There's the gyroscope and the device orientation API and a whole bunch of other ones. And so all of the code demos and everything that you need is here. And pull request accepted. Right? If you do something really cool, send me a pull request. I would love to include it. It's on GitHub. I don't know if you're all familiar with that. But yeah, thank you very much, and I'd love to talk to everyone after this. Thank you.